I did a summary for chapter 6. You can see all formulas that you will need. So you should know how to apply these formulas. Okay? So here, for example, for the
وضع مثل
yes, in this chapter, if you want, it's similar to chapter 5, but now on the micro scale. So we are applying conservation and momentum on micro scale. That's it. Okay? So we have equations for conservation of mass. This is here you can see the general. Do you see? Just 1 second. I will.
it's frozen.
Yes, let me share the screen. You see now the formula sheet?
Yes.
Okay, so you have mainly conservation of mass and Navier-Stokes equation. Conservation of mass is the same concept so of chapter 5 when we did conservation for a controlled volume, but here we take a very small fluid element. Okay, so the condition for conservation of mass, the general relation is this one. So this is here the general conservation of mass. Now, if you have a steady application, you can simplify. If it's steady, you will cancel del rho by del T. If it's incompressible, you can take rho outside, okay? And when you take it outside from the 3 terms, it will simplify. So if steady and incompressible, you use this relation, okay? And in general, we have we have several systems we can work on. We can work in Cartesian coordinates x, y, z, which are perpendicular. This is the one you are used to. Also, we can have polar coordinates. So in polar coordinates, your equation becomes of this form, okay? So it is a little bit more complex than x, y, z. But what you should know is to know the formula and you apply it. You don't have to remember anything, just to know if you are working in polar coordinates, use this formula, okay? Now, for the Navier-Stokes equation, it is the application of linear momentum on the small fluid element, okay? So you can see here that they seem very complex, but when you do problems, it's simple, because in problems, a lot of terms will be simplified. So here you can see, for example, from this side, you have the forces. This term is for pressure forces. This term is for weight. This term is for viscous forces. Okay, and you have Navier-Stokes equation in rectangular components, and you have Navier-Stokes equation in polar coordinates. So mainly, these are the main formulas we are using. And the course material is to just introduce you to these relations and how we got them. Okay? So now let us start doing the problems.
دكتور انت بنستعمل النافيرز امتى الكونسرفيشن اوف ماس؟
هلا بنشوف يعني عادة when you want information about the velocity field مثل بالchapter 5 نفس الكونسبت. When you want to know something about the velocity field, you use conservation of mass. When you want to get information about forces, pressure forces, viscous forces, you use Navier-Stokes equation. Okay? Yeah, let us when we apply them, you will understand them better in problems. Okay? So first, let us start with the first problem. So here, for example, a reasonable approximation for the two-dimensional incompressible laminar boundary layer on a flat surface is given in the figure. You have the velocity field u is given function of y and delta, and we have delta function of x. So let us look at the figure to understand our flow. We have in this figure, we have a 2D flow. This is your x direction, and this is y. Okay? Now, what is happening is that for any x, for each x, okay, you have a certain variation of profile. So here, if you want, the profile is similar, but what is different from one location to other is the thickness of your boundary layer. Okay? So here, with x, the variable is delta. Delta, which is the thickness of the boundary layer, is varying with x only. This is why they gave you here thickness of boundary layer delta equal to a constant times x to the power 1 over 2. Okay, so delta is only function of x, which is the thickness. And for each x location, I have the velocity profile varying function of y. Because you know that due to the no-slip condition, when you have a flow over a fixed plate, at the plate level, the velocity will be 0. Then the velocity will increase smoothly due to viscous effect until reaching the uniform velocity at the end. Okay? So if you want, at y equal to delta, the velocity becomes equal to the uniform velocity of the flow. And this profile is given by the following equation. So they gave us u function of y and x because delta is function of x. Okay? Now, what they want us to do is they say, assuming a no-slip condition at the wall, find an expression for the velocity component v along xy. So in general, always the notation is u, v, w. So u is the component of the velocity field component along x. V is the component along y. And W is the component of the velocity field along Z. But here we have a 2D flow, so we don't have a component of the flow along Z. Here it is equal to 0. So we have only U and V, okay? Now, they gave us U, they need us to find V. So as we said, we need to find a velocity. So we go to our formula sheet, we look at the conservation of mass. And from the given, they said, it is incompressible. It's an incompressible flow, incompressible steady, because we don't have any function of time here. It's not function of time. Okay? So what we will do is we go to the formula sheet here. We look our equation. What is the equation to use? The equation to use is this one. Del u by del x plus del v by del y plus del w by del z equal to 0. But in our problem, we said it's a 2D problem, no velocity in z. So delta w by del z is 0. So in this problem, what will be our equation? Del u by del x plus del v by del y equals to 0. So if I go back to my problem, I will just write that my condition, okay? So my condition is, I write it here. The condition is del u by del x plus del v by del y equals to 0. Equals to 0. So I can deduce that del v by del y is equal to minus del u by del x. Okay? Now, what can I do now? Now I have u. U is given. Okay? So if I go back to, I should go back to my expression of u, okay, and derive u with respect to x. When I derive u with respect to x, I obtain del v by del y. Okay? Then to find v, I integrate over 1. So first, let us bring the expression of u. So this is the expression of u. Okay? It's u times 2y over delta minus y square over delta square. So let us derive this expression with respect to x. Okay? So I'll write here now that del v over del y is equal to, if I derive this relation with respect to x, please keep in mind, when I do, del is partial derivative, okay? So when I do del v by del y, I consider that delta, in this case, is constant. And then when I do del u by del x, I derive u with respect to x, I consider that y is a constant. So I will write del v by del y is equal to minus del u by del x. So
اوكي
now
قصدك y constant مش دلتا.
نعم.
قصدك y constant مش دلتا. صح؟
لما كنت عم تقولي عن del u by del x ناخذ ال y.
What del u by del x y constant, yes.
أوكي.
مظبوط، الثاني الاكس.
Okay. So minus del u by del x. Now اكيد هون ما بحسب دلتا constant، بس اعمل del u by del x دلتا ما فيني احسبها constant لانه هي function of x، بس اعمل del u by del x اللي بحسبه constant هو y، لانه انا my two variables هن x and y and I'm doing partial derivative of u with respect to x. بينما اذا عم بعمل del v by del y ساعتها بحسب الدلتا اللي هي constant والy اللي هي الvariable. Okay, but now I have u function of y and x, so I will do del u by del x. To do del u by del x, you have u times for the first term قلنا delta we consider it y we consider it as a constant، يعني الفانكشن تبعنا هي delta، صح؟ And you know that when we have a function of x and we want to derive, we can do the chain rule. What do I mean by the chain rule? يعني we consider that we have like it's if you have 2y over u, okay? So the derivative will be of the following form. You have 2y times, you should do the derivative of this term with respect to x times what? Times the derivative of delta with respect to x. And when you have a function and you want to derive it, okay, you derive the function, but you should multiply again by what? By u prime, okay? So here, since delta is a function of x, I will multiply by d delta by dx. So derivative, if you want, because it's not, it will not be d delta. Let us write it like
فينا نعمل replace بدل دلتا ونعمل derivative عادي.
فينا نعمل replace أكيد مظبوط. It's another possibility. Okay, فينا نحط محل دلتا دغري cx to the power half ونعملها، أو فينا نكتب هيك d delta with respect to x times if you are deriving إذا عندي 1 over delta شو الديريفاتيف تبعها؟ minus 1 over delta square، يعني times minus 1 over delta square. أو إذا بدكم if you feel easier إنه you replace delta directly by constant x to the power half وبتعملوا derivation ساعتها direct. Okay, we can do this also, both are right. أصلاً هلا d delta by dx, we should derive delta with respect to x. What is d delta by dx? If I derive it, you know that إذا عندي x to the power إذا عندي x to the power n, what will be the derivative? If I derive, I get n x to the power n minus 1. Okay, so if I replace my term here بصير عندي 2y times the derivative of delta with respect to x اللي هي the constant c times half 0.5 times x.
دكتور مش احسن بكتير اذا بنعمل دلتا equal cx to the power half نحطها بالفورمولا ونعمل derivative with respect to x؟
مبلا قلت لكم فيكم تعملوها هيك، فيكم تعملوها مثل ما بدكم. اوكي مبلا اهين it's true. اوكي اذا بدكم تنعملها دغري هيك if you feel it's much easier. So if we replace directly, we put here c x to the power 0.5. اوكي بصير كانه عنا حنكتبها هون، يعني بنكتب u equal to big U times 2y times c times x to the power over c. اوكي حاخد x لفوق بحطها x to the power minus half x to the power minus 0.5. okay, and then for the second term I have minus y square and over c square and times x to the power minus 1. okay, times x to the power minus 1 over c square. So now if I want to do as you said like this, it will be easier. If I do now del u by del x, I get del u over del
Doctor,
x.
can you admit Noor?
Yes. So del u by del x, as we said, y we treat it as a constant. Okay, so you have u times 2y. Now x to the power minus 0.5. If I derive it, it is minus 0.5x. So minus 0.5x to the power x to the power minus 1.5, minus 1.5. Okay, over c, over the constant c. And for the second term, I have minus y squared, minus y squared. Now for the derivative of x minus 1, it's minus x to the power minus 2. So minus x to the power minus 2. Okay, and over c squared. So now I got del u by del x. Okay, it is equal to, and del u by del x is equal to minus del v over del y. Okay, so now what will I do to find v? I will integrate this relation with respect to what? With respect to y. Okay, and when I integrate with respect to y, I will consider that the x is a constant. Okay, and here the integration is simple because with respect to y it's not complex. So let us do it. Okay, so when I integrate, what are the boundaries of my integration? I will integrate from v from 0 to v, and y from 0 to what?
Y.
Yes. Okay, because why I am doing from 0? Because due to the no slip condition, what you can write? So I can write here, I will write that due to the no slip condition, due to no slip condition, when y equal to 0, when y equal to 0, I have v equal to 0. Okay, so I will integrate for y from 0 to y and from v from 0 to v. Okay, so if I do the integration like this, I will obtain the following. I will obtain that v is equal, by integrating this term here with respect to y. Okay, what do I get? I have u times the integration of 2y will give me y square. So y square times the remaining term, I will take it as it is because I consider x as a constant. So minus 0.5x to the power minus 1.5 over c. And for the second term, I have minus the derivative of y square is y cubed over 3. So minus y cubed over 3 times minus x to the power minus 2 over c square. Okay, and in this way I have obtained the relation between of v. I have obtained v function of x and y. Okay, now next question. Any question on this part? Okay, so after doing this, the next step they told us, find the maximum value of v for x equal to 1 meter. Okay, so هلا هن they did the other method I was doing for you. هلا it seems it's complex, but in reality this method اللي هن عملوها will give you الفورم, the final form تبعكم حتصير يعني much simpler. يعني مفروض هيديك الميثود اهين، بس هون directly look it's arranged directly function of delta. This is why كان بدي اعمل لكم chain rule. Anyway, the both methods will lead to the same result. يعني you will get v equal to u times d delta over dx, times y square over 2 delta square and y cube over 3 delta cube. Okay. Now, they said that we want to find the maximum velocity. To find the maximum velocity, you should have the derivative del v by del y 0. You know this, okay? So the maximum velocity, the maximum value of v correspond to del v by del y equals to 0. And to do this, you have here already the expression of del v by del y. So if you put that del v by del y equals to 0 and you solve it, you get that it is 0 for y equal to delta. Okay, and this is expected because as you go far from your flat surface, the velocity is increasing. Okay, so now if I want to find the value of v, the maximum value of v, I should replace y by delta. Okay, and to do this numerically, they asked for x equal 1 meter. So already you have delta function of x. So you replace for x equal 1 meter, you replace in the equation of delta, you get delta, and you will obtain the numerical value of delta will be 0.011. And now, once you find it, to find v maximum, you go back to the expression of velocity and you replace y by delta. So let us do it together. V max is for y equal to, so V maximum correspond to y equals to delta. If I replace in my equation, in this equation here, I get 2, it's equal to 2u times d delta by dx, d of delta over dx, times if I replace here y by delta, I get delta square over 2 delta, which is 1 over 2. And here I have delta cube over 3 delta cube, so minus 1 over 3. Okay, so I get, in this case, 1 over 2 minus 1 over 3, it's 1 over 6. Okay, and if you replace
دكتور بس شو قصدك بدي دي دلتا باي دي اكس؟
يعني الديريفاتيف of delta with respect to x، يعني هيدا derivative of delta with respect to x. مش انتوا معكم delta function of x, it's given that delta is equal to what? If you go back to the given, okay, delta is cx to the power 1 over 2. So d delta by dx, if I derive this relation with respect to x, I get d delta by dx equals to 1 over 2 times c times radical of x over radical of x. Okay, so by just deriving delta with respect to x, you get c over 2 radical x. Okay, and you can replace it also by delta over 2x. So what they did here, all they did, they replaced d delta by dx in the formula. So if you replace d delta by dx in this formula here, you can replace it by delta over 2x. And when you apply at y equal to delta, you have here 1 over 2 minus 1 over 3, which will give you 1 over 6. So if you replace, you get v max equal to u delta over 6x. And putting the numbers, you can get your maximum value at this x. Okay, and v max will vary with x. So for each x location, you have a new delta and you have a new maximum velocity. Okay.
دكتور إذا استعملنا تاني طريقة من الديريفيشن كيف كنا وصلنا لدي
ما
دلتا باي دي
بيأثر، ما اصلا اذا عملت تاني طريقه من الديريفيشن، بدل ما تعمل فانكشن اوف دلتا شو بتحطها؟ فانكشن اوف اكس، صح؟ وبترجع بتوصل لنفس الريزلت، ما اصلا هي دلتا مش a function of x. يعني اذا بتحط مطرح دلتا c over 2 radical x here، بيرجع بيطلع لك الجواب اللي انت حيطلع لك اياه، لانه انت you don't want delta, you want to express only function of x. So you will get this result. إذا اشتغلت بتاني ميثود اللي بتناقشنا فيها سوا، you will get v max equals to u instead of delta. You will have the expression of delta اللي هي c x to the power 1 over 2. Okay, to the power 0.5 و over 6x، يعني نفس الريزلت. اوكي يعني مش مشكله ما نكون مجبورين تعطوا function of delta الا اذا هن قالوا لكم find the maximum function of delta ساعتها it's easier to go in this way the way they did.
احنا كيف وصلنا لهيدي الفي ماكسيموم من هالايكويشن؟
وصلنا للفي ماكسيمم قلنا انه v maximum correspond to del v by del y equals 0 مظبوط. وقت عملنا وقت عملنا الديريفاتيف del v by del y equals 0 if you replace here equals 0 بيطلع لك انه this is satisfied for y equal to delta. يعني if you solve that this term is 0 لانه خد دي delta by دي x into factor شو بتصير الكونديشن؟ بصير عندك minus 2y over delta square plus 2y square 2y square over delta cube should be equal to 0. Okay, so one if you simplify you get so the condition is y equal to delta. Okay, يعني the maximum v takes place at y equals to delta. This is why I will replace in this equation y by delta to get my maximum velocity. Okay. Any other question? Okay. Let us pass to another problem. A piston compresses a gas in a cylinder by moving at constant speed v, as shown in the figure. Let the gas density and length at t equals 0 be ρ0 and L0 respectively. And let the gas velocity vary in a linear way from u equal to big V at the piston face to u equals 0 at x equal to L. If the gas density varies only with time, find an expression for rho function of time. So first, here it's unsteady because they said already that we have variation with time. Okay, and we want to find rho function of time. So of course we should think about continuity because continuity involves variation of rho with respect to t. So if I go back to my formula sheet and I look at the relation I should use, okay, here what relation should I use? I should use the relation for unsteady application. So I will look at this relation, okay, but in my system I have 1D motion because you have a piston moving in the horizontal direction. So I only have u, no v, no w. So v equals 0 and w equals 0. So this equation in this problem will be simplified because I only have u, I don't have v, and I don't have w. Okay, so now I will write that in my problem del rho by del t plus del rho u by del x equal to 0. So let us put it here. So I will say I will use the following relation del rho, it's written here, del rho by del t plus del by del x rho u equals to 0. Okay, now so 0 equal to 0. Now how can I simplify this relation more? They said that density is only function of time. So here if you look at this sentence, the density of the gas varies only with time. So the density is not function of space. This is why here you can take this rho outside of the derivation. So your result will be del rho by del t plus rho del u by del x is equal to 0. Okay? Now, how to continue? To be able to continue my problem, I should find u function of x because I want to derive u with respect to x. And in the given, they gave me the hint. They said that assume u varying in a linear way, and they said that at x equal to 0, so at x equal to 0, we have velocity equal to v, which is a constant, okay? And at x equal L, so at the end of my piston here, at the end of my piston, the condition is that v u is equal to 0. Okay, so you have a linear variation and you have 2 points. So you know that to find the equation for a line you only need 2 points. So here our 2 points are for x equals 0 u equals 0, sorry, u equal v. For x equals 0 u equal big V, and for x equal L u equals 0. So if I write the equation in a linear form, I write that u is equal to ax plus b, where a is the slope. Okay, a represents the slope. It will be equal to delta u by delta x. So delta u over delta x, which is equal to the slope. Okay, what is the slope here? Delta u is 0 minus v, so it's equal to 0 minus big V over L minus 0 over L minus 0. So here the slope of variation is minus V over L. Okay, so this is what you need. What you need is delta u by delta x. So delta u by delta x is the slope of variation of u with respect to x is equal to minus v over L. So you can replace in this relation, you replace del u by del x by minus v over L. Okay, what will be our result then? We will get that
يطلع
zero-
B equal V.
yeah, sorry,
يطلع B equal V.
yes. Okay, so now
بس دي دكتور لقينا السلوب بعدين شو عملنا؟
نعم، شو عملنا؟ لقينا السلوب. من بعد ما لقينا السلوب شو الايكويشن تبع يو؟ تطلع الايكويشن تبع يو minus v over L times x. Okay, now to find b we use the boundary condition. To find b we say what is the value of b? To find b we say at x equals 0 what is the velocity? It's big V. Okay, we have at x equals 0 u equal to big V. So what is b? So if you replace you get b equal to big V. Okay, يعني I can say that my function u is equal to minus v over lx minus v over L times x plus big V. Okay, and if you want, if you take big V into factor, you get 1 minus x over L. Now what you want del u by del x. Del u by del x is the slope of variation of u with respect to x. What is the slope? It's a. It's the coefficient of x, which is minus v over L. Okay, so here you can replace del u by del x by minus v over L, because if you derive this relation with respect to x, you get minus v over L. So now, replacing in your equation, you obtain the following. You obtain that del rho by del t, or if you want, we can write d rho by dt, because rho is only function of time. D rho by dt is equal to minus a rho times del u by del x. But since we have minus here also, so minus minus, it's plus. So it is equal to v over L times rho. Okay, now how to continue now? Now I should do separation of variables. I have two variables, rho and t. Okay, so by separating variable I get the following. D rho over rho is equal to v over L times dt. But please pay attention, L is variable, but function of what? L is the length of my here of the in the cylinder. This is L, and with time L is decreasing. Okay, but who will tell me how can I find the variation of L with time? So because as I move my piston, L will decrease. Okay, but L can be directly related to time because I am pushing my piston at constant velocity. Okay, so L will decrease in a linear way with time. And I can put the following condition that the variation of L is equal to, at any time, it's equal to minus Vt, because it's decreasing at velocity V, and to find the constant, so plus constant. Okay, how to find the constant? They gave me the initial length of the inside the cylinder. They gave me L0. Okay, so I can say at t equals 0, at t equals to 0, I have L equals to L0. So replacing in the equation, I get that the constant is equal to L0. So now I found the expression of L. L, of which is a function of time, is equal to minus Vt plus L0.
Okay, let's minus VT.
ليه minus Vt؟ لأنه الفيلوسيتي شو هي الديفينيشن تبعها؟ مش هي dx by dt؟ velocity v
rate of change
هي الفاريشن of length، مظبوط؟ dx over dt، يعني هي الفيلوسيتي by definition هي السلوب of variation of length، مظبوط؟ with respect to time، يعني أنت لأنه v constant the length will vary in a linear way. It's linear لأنه v constant. Okay, لو velocity is not constant ساعتها you write that dx equal v dt ساعتها and you integrate. But here because v is constant you can directly say that the variation of length will be linear and the slope of variation will be equal to minus v because it's decreasing at a rate equal to v. Okay, which is a constant. So the form of L is minus Vt plus constant. And to find this constant, we apply the boundary condition that at t equals 0, L is equal to L0. So we got now L as a function of time. So all we have to do now is to do separation of variables because we got a relation which has